Hello, so we are starting our very exciting next unit, and the main idea of this unit is that we're talking about linear models. So we spent a lot of time last unit talking about linear equations, and now we're going to talk about what it means to make a linear model. There's also going to be a few other things that are like background knowledge or potentially like new knowledge that we don't know about yet. That we're going to be adding into this unit to be able to fully, truly understand all of the elements that go into creating a model of a linear wave. Hey, a model is just an equation. That's all it is. It's just an equation that represents that situation. So it's modeling that situation. And so there's a lot of things that go into it. And one of the things that goes into it is determining whether or not something is a function. And before we even delve into that, which is what our first lesson is about, we need to just do kind of like a preparation before finding out whether something is a function. Anything can be a relation, right? It's short for relationship. So it's a relationship between anything. And so for the purpose of the argument that we're normally talking about, a relationship between two variables. On the x-axis compared to the y-axis, what's the relationship between these two variables? It could be a parabola, it could be a line, it could be an exponential equation, it could be a trinomial, or a cubic. So there's so many different ways that we represent relationships. Most of the time they are functions, but not all the time. But very first, beginning, all-encompassing, big umbrella over everything is we have relationships. And because we're only focusing on coordinate planes in this class, two-dimensional coordinate planes, we don't really focus on three-dimensional all that much. We're only going to focus on the relationship between two variables. Just realize that all of these things that I'm going to talk about right here could also be with 3, 4, 5 infinite variables. But really what we're focusing on is the relationship between two variables. And these are all of the different ways that you can see relationships. These are like the 5 ways that I can think of that we see relationships, or relations for short. And one way that we see relations is tables. So for instance, we have like, okay, here's x and here is y, and we say, okay, here's -1, 0, 1, and maybe it goes to 1, 0, -1. Right? And so really what this table is it's a set of points, right? You would say, oh, okay, -1, 1 means that I have a value of, or a coordinate or an ordered pair of -1, 1, right? That's typically what we take away from a table is we take this table and we turn it into a graph, or maybe we take a graph and we turn it into a table, but it's some sort of relationship, right? And it could be a relationship that looks like this. It could be 1, 2, 3, 4, 3, 3, 3, 3. Right? And what that means is no matter what, y is always equal to 3, which we know is a horizontal line at 3. Right? So there's all sorts of different ways that tables work, but the main idea with a table is that it's very clearly like this belongs to this, this belongs to this, this belongs to this, that there's an ordered pair that comes from it. And that's typically what we take away from tables. A different way that we see it is a graph, right? So we could have a series of points on a graph. So we could just have like something that we call a scatter plot. This is a relation. Is it a function? No, but we'll talk about that. But this is a relation, okay? We could also have a relation that looks like this. We could also have a relation that looks like this. So all of these are relations, right? Whether it's just dots or whether it's a continuous line, continuous curve. It could also just be a line, right? So all of these are a graphical representation of a relation. And the whole purpose with a graphical representation is to get a visual understanding of what the relationship is, right? We can say like, oh, as we move up in the x value, we also move up in the y value. There's this idea of like, as we continue, we get bigger and bigger and bigger. And that's just kind of a nice visual cue to us of what's going on, as opposed to sometimes in a table. I'm sure most of you feel, because I definitely feel this way, but sometimes when I look at a table, I'm like, I don't really know what's going on there. It's hard for me to tell. But once I put it on a graph, I'm like, oh, that's what's going on. Okay. Another way that we can talk about relations is algebraically. We can write equations, right? So we could have something like x squared plus y equals 1, or negative x squared plus y squared equals 4. Or we could do, there's an infinite number of relationships. We could do x to the 5th power equals y, or x minus y equals 0. There's so many different ways that we can represent it. But this is also a relationship that, hey, once we start bringing these x and y variables into each other, then they kind of have this play on each other of like, okay, if maybe I plug in something for x, maybe it'll give me back what y is. I like to think of algebraic representations of relationships, or in other words, equations. I like to think of them as a computer, that, hey, we've got this like program that you've programmed into your computer that says like, this is what we're going to do every single time. And an equation is saying, okay, well then if you plug in something for x, I'm going to do a few things. I'm going to do a few mathematics. I'm going to square that number and then subtract it from both sides, right? It's a set of instructions for you as a computer to follow in order to solve for y. That's all these equations are for. It's showing a relationship between these two variables, and it's almost behaving like a computer or a set of instructions of like, here's how you find all of the things that would fit inside of this relationship. So these are all ways that we have normally seen relationships, and they're all ways that I think that we feel somewhat comfortable with the relationship between all of them. A few other ways that we can also represent relationships that I've noticed that a lot of students get really stuck on is set notation as well as mapping diagram. And I think it's just mostly because we don't see it very often. So we're going to take today to talk about mostly these two to get you a little bit more familiar with them. So then that way the conversations in our following lessons hopefully will be a little bit more easy to go. So set notation is a set. So remember that we always represent a set in curly brackets. And a set notation is just a set of points. So it's very similar to your table where it's just giving you coordinates or points, but instead of seeing them like this, we're just seeing it as a list of points. So for instance, this set of 3 points would be -1, 1, comma, 0, 0, comma, 1, -1. And that is the end of the set of the points. Realize that this relationship ends and begins with just those 3 points. There is no line connecting them because we're just saying this is the relationship. This point, and this point. That's it. There's no line connecting them. There's no curve. There's no points in between. So we couldn't do like 0.5 or something and be like, oh, well, if you connect the line, then there's going to be all these points in between. There are no more points. It is just those 3. Same with the table. It's just those 3 points, or here, those 4 points. You could also have just 1 point, that the relationship is just, hey, this is your 1 point of 4, 5. Or you could have an infinite list where you might try and determine a pattern, right? 0, 0, 1, 1, 2, 2, ... Or sometimes we can have 2 sets that relate to each other. So instead of listing out points, as you can see below, we kind of have some sort of set notation that follows what I'm about to say. You could have a list of your x values. Okay, that's going to be, if we followed like this guy up here, 0, 1, 2, 3, ... And then you could have a set of all of your y values that go with it. Well, 0 goes with 0, 1 goes with 1, 2 goes with 2. Oh, 3 is going to go with 3, and so on, right? So there's kind of 2 different ways that you can do it, but just realize that a set is exactly as it means in the English language. It's a collection of something. So you've collected either a set of points, or maybe you've collected a set of x values that go with another set of y values. But this is another way that we show relations, the relationship between an x value and a y value. Only 2. We can talk about 3-dimensional. We can talk about 4-dimensional. We can talk about a whole bunch of other dimensions, but this is all that we're focusing on. The 5th and final way that we tend to see relations, and it's very common when we talk about the question of is it a function, is a mapping diagram. And really a mapping diagram is just a really fancy table, because all it is an oval which represents your x values and an oval that represents your y values, and then you have arrows in between. So like, let's say we had these values for x, -3, 1, 1, and 2, and then let's say that we had these values for y, then we would say like, okay, well, -3 goes to -1. And maybe like -1 goes to -2. Maybe 1 also goes to -1, and then maybe 2 goes to 0. You can create a set of points from that, just like you can create a set of points from the table. Notice that a table is a little bit clearer, right? We go just right across the line. That is our point. Whereas here we just have to follow the arrows. -3 goes to 1. I plug in -3 into an algebraic expression, and the computer gives me back -1 as a result. You could also do -1, -2, and 1, -1, and 2, 0, right? So that's all a mapping diagram is it's just a really fancy table, and instead of it just being very clearly like, hey, this goes to this, this goes to this, this goes to this, there's arrows, which just makes it a little bit more confusing, maybe, but I don't really think that hard, which is, I think, why we typically stick with tables. But that's all a mapping diagram is. Similarly to like this table where everything goes to 3, if I wanted to represent that in a mapping diagram, I could do like 1, 2, 3, 4, and then y value of 3. And I would say, okay, well then 1 goes to 3, 2 goes to 3, 3 goes to 3, and 4 goes to 3. And that's representing the relation of y equals 3, that horizontal line of no matter what, we're just going to 3. Okay, so these are the 5 main ways that we can see relations, okay? Just like a relationship between x and y. We're going to practice a few more like basic IB questions that revolve around just an understanding of relations. Okay. So Charlotte is working on an environmental project and is analyzing the amount of paper used to print some books. She finds out that to print 1 copy of a certain book, 6 meters squared of a particular type of paper is needed. Let A be the set of numbers of copies of books. So this is a set notation of all of my A values. And B is the set of the amount of M squared of the paper needed to print the number of copies. And so we're comparing them kind of like how we did up here, how like, oh, 0, 0 went with 0, 0, 1, 1 went with 1, 1. And notice that, okay, well then 1 goes to 6, 2 goes to 12, 3 goes to 18. And so it says find the values of M, and all we're doing is we're continuing that relationship. How did we get from 1 to 6? How did we get from 2 to 12? How did we get from 3 to 18? Are they the same? How did we move from one to the next? What we're looking for here is some sort of relationship. Hopefully we notice that if you multiplied by 6, you get all of those values. 1 times 6, 2 times 6, 3 times 6, which means in order to find M is just 4 times 6, 24. N would be then what? N would be then your last one, 5 times 6, which is 30. That is M and N. The final one just says write down the set of ordered pairs for this relation. So now this is the set of our A values and the set of our B values, in other words, our X and our Y values. And then writing it down now as ordered pairs means that we want a set of all of our ordered pairs. So that would be 1, 6, 2, 12, 3, 18, 4, 24, and why don't you tell me what our last ordered pair would be? It would be the combination of 5 and N, which is 5, 30. And that's it. So this is one way to represent a relationship. Ordered pairs, one that we don't normally see, or sorry, set notation is the one that we don't tend to see very often.